and we were looking at geometric series. So this time we're told the sum of the first two terms of a geometric series is 25.5. The sum to infinity of the series is 30. Given that the common ratio is positive, find the common ratio of the first term of this geometric series. Now, there's two ways to do the first bit. I'm going to go for what I think is the easier way. When it says the sum of the first two series is 25, and then it says sum to infinity is 30. We've got two formulas we can write there. Now, I would probably prefer, for part B, to say u1 plus u2 is equal to 25.5. But what you could do is you could write S2 because it's the sum of the first two. I think it's a little bit of overkill. It's like using a sledgehammer to crack a nut. Okay? What are we laughing at there? You like that one, do we? We're also told sum of infinity is equal to 30. Okay. U1, we already know from our proof, is A. U2, we already know from our proof, is AR equals 25.5. Just leave it as that for now. We may do some factorising, we may do some dividing. We'll worry about that in a second. S to infinity, now that is given in the formula booklet. That is A and then 1 minus I. It's basically that bit there, but minus the bracket there. Okay? But if you get a sum to infinity, what's that tell us about the ratio? It tells us it has to be smaller than 1. It has to be a decimal, either positive or negative. I.e., if this number was 10, and my ratio was, say, 2, this term would be 20, then 40, then 80, then 160, and so on. It would be getting bigger and bigger and bigger. So the sum to infinity would be infinity. You're eventually going to get to a huge number. However, this is 10, and that the ratio is 0.5. It's be 5, 2.5, 1.25, and so on and so on and so on. Eventually, you're going to get so small that it doesn't exist, and then you're just adding up all those terms together to get what's called a sum to infinity. Okay? So that means that the ratio has got to be a fraction, positive or negative, but it tells us somewhere that's positive. I've read it already, okay? Okay, I think the best way to do this is probably to rearrange this one here as 30, bracket 1 minus r, and sub that in place of a. Personally, that's not the only way. There's lots of different ways to do these. So I'm going to say sub 2 in 1. So wherever we see an A, we change it to that 31 minus r bit, okay? Okay, so that's what I've got so far. Expand the bracket, 30 minus 30r. 30 times r is 30r, so then times that by 1 is plus 30r. And then we get 30r times by minus r, which would be minus 30r squared, is equal to 25.5. Agreed? I need a little bit of feedback as well. If you're happy with that, just let me know, okay? Yeah. I can see some cancelling there. That's going to cancel with that, isn't it? Then I've got an r squared and a number. Oh, okay, this is going to work out much nicer than I thought it was, actually. I don't like that being negative. So let's take that over to the other side and get 30r squared. But let's bring the 25.5 over. What do we get? 4.8. Take the 30 over. I'm hoping 4.8 divided by 30 goes to a really nice number. It may not do, though. Lovely. Any idea why I'm saying lovely? Because that is a lovely number. They're both square numbers, aren't they? And r is squared. So when we take the squared over, it becomes... Now, technically, it's plus or minus, isn't it? And that goes into our calculator. It's just 2 over 5. It's 0.4. I'll show you. But why can I take it as positive? No, the ratio could be anything, to be honest. I could times, so like I could times it by minus 0.4 as well. But in the question, it says it. Okay, that's the only reason why. I was expecting to create a quadratic then and then do some factorising, but luckily we didn't have to. Okay. Have I done what it asked though? It said find the ratio. Done. Find the first term. I haven't found the first term, so I need to sub r is 0.4 into 1 or 2. I'm going to do it into 2. into A is equal 30, 1 minus 0.4, 18. Any idea how I did it in my head? If you're there thinking how to do that in his head? Well, that's going to be 0.6, and 0.6 is the same as 60%. I just found 60% of 30, which is 18, okay? You don't have to do that though, you've got to calculate it. Okay? Number 6. So what's number 6 asking me? What's it all about? Integration, okay? So what's the rule that we have going around our head in loop as soon as we start thinking of integration? Power up by 1, divide by the new power. When we write out question A, we do not write it the way it looks. We're going to write that in indice form straight away. So that is going to become 4x to the power of minus 3 minus x minus 3x to the 1/4 dx. That's how we're going to write it down. That's the same thing. We're lucky they didn't put 4 through there. They could have put 4 through in their question, then we would have changed that to a quarter anyway, okay? So, when we integrate it, the power goes up by 1. So we get 4x to the power of minus, go on, 2, divided by the new power. So divided by minus 2. And then it's going to be minus 3x to the, what's a quarter add 1? 5 quarters. If in doubt, chuck into your calculator. You've got a calculator in this exam, okay? So the 5 over 4 divided by 5 over 4 plus c. We need to do a little bit of neatening out just before we're certain of getting those 2 marks, okay? How are we going to neaten it out? Well, how many times does minus 2 go into 4? Negative 2. You can leave the indices negative. There's no need to change that back. You can if you want to. You could say it's minus 2 over x squared. I wouldn't bother though. And this one here, what's 3 divided by 5 over 4? We'll chuck it into your calculator. 3 divided by 5 over 4 is 12/5. There's another way you can do it, which is effectively your times and by its reciprocal. So you do 3 times by 4 to get the 12, and then the 5 stays on the bottom. So minus 12x to 5 quarters over 5 plus c. Okay? Part B. Now we're looking for the equations of these graphs. There's one. We told anything else? Oh, it's just one. It's just one graph, isn't it? Okay. Now this is more for our information than anything else. You wouldn't write this in the exam. I'm just telling you now. This will come up as negative. Good. Very good. This will come up as negative. We take the positive answer. Why is it coming up as negative? Because it's under the graph. Perfect. Okay. We need to work out where this value is and this value is. How can we do that? It's all related to the graphs. At the x-axis, the y value is 0. We haven't got up at all. Okay. So I'd say at A and B, colon y equals 0. Therefore, 0 equals 4 minus x squared. Don't like the x squared being negative. Take it over, it becomes x squared equals 4. Take the squared over, it becomes A-level answer? Plus or minus 2. So A must be, therefore A is minus 2, 0. And B is 2, 0. All good? Lovely. Part 2, find the total area of the shaded regions. Okay, so to find the total area, we need to come up with a formula in integrals. Integrals find the area under the graph between its x values. We're told what C is as well. We're told here that C is 3, 0. Okay, it tells me in the question. So I want to know all of that area here. I want to know all of that. So I'm looking at its x value there, which is 2, and this value here, which is minus 2. So that'll be my integral between 2 and minus 2, and it's of that curve. So we could write curve, but I'm just trying to save a line of work and just writing what the equation of that curve is straight away. And technically, I should be saying dx there. Okay, that's just telling me to put the x powers up by 1, blah, blah, blah. And then we want to add this bit of area here, which is what are the x values for that bit of the curve? Say again? 2 and 3. Which way does the 2 and 3 go around here? Yeah, 2 on the bottom, 3 on the top. You always go biggest, then the smallest there. That's not strictly true in C4. Just James, a bit of a head up. This is the way it goes, but don't worry about that now. Okay, it's just I don't want you next year. Oh, our teacher said this last year. It's like, In 95% of the cases, it's true. Okay, so 4 minus x squared dx. Okay, but we've got to be wary that that's going to be a negative answer. We know already it's going to be negative. We've got to take that as positive. So I might just highlight that and say, but take a positive answer. Okay. Integral of the first bit, power up by 1 divided by the new power. So 4 power up by 1 becomes, easy, just 4x. X squared becomes x cubed over 3. And then we're subbing in 2 minus 2. Then we want to add, and then it's exactly the same thing. X cubed over 3. And then 3 and 2. Okay? Sub in slowly. If you rush this, you'll mess it up, I guarantee it. We're going to get 4 lots of 2 minus 2 cubed over 3. And then we're going to take away when I sub in exactly the same thing, but with a minus 2 instead. Just about squeezed it in. Okay, so I'm just focusing on the first bracket. That's all I'm focusing on. I'm not even going to put those brackets around it. I'm just working out that bit there. So 4 lots of 2 minus 2 cubed over 3. Okay, so I've got the answer there, 16 over 3, but I can sort of go and chuck that somewhere else. Any idea how? Yeah, I've got it, that and that are the same, aren't they? Look. This chap is this chap. So we can say take away 16 over 3 here. Okay, now I just need to change the 2's to minus 2, so I'm using my old friend the replay button. We like him, because he saves us lots of work. And I'm a bit mini pleased with that answer in hindsight. Why am I mini pleased to have that and that? It's clearly a symmetrical graph, isn't it? So if that area there is 16 over 3 units, then it makes sense that that area there is 16 over 3 units, doesn't it? Okay. Now this one here, I need to go and change the minus 2 to 3's, which comes out as being 3. So 16 over 3, take away minus 16 over 3 is just 16 over 3 times by 2, which comes out as being 32 over 3. And then we want to add, and then 3 take away 16 over 3. There we go. We said that, didn't we? We're way ahead of the curve here. So, oh, we're doing curves as well. Yes. So we're going to really add, we're going to ignore that minus, we're really going to add 7 over 3. So then 32 over 3, add 7 over 3, isn't it 13, I think? Check it. It's not worth the risk, is it? Oh, yes. 13 units squared. Okay, on to the last page now. If you'd all turned up at the end of break, we would be able to finish this exam. It's my little dig for the day done. Lovely. Okay, logarithms. We like logs. If I'm being honest off the top of my head, I don't know if I know the log proofs. I'm going to have a go. Okay? You do something like let P equal log base A of x and Q equal log base A of y. And you have to know that. It is this one, adding. Okay. Now, use my rules of logarithms. I can bring that A over here. It swings into the P and knocks P into being a little power. And then leaves just the x in there, okay? And that's the definition of log, so you need to know that bit. And then same here would give me a to the q is equal to y. In the question, it tells me to do x times by y. Look, it says it there. So, x times by y, xy would equal a to the p times by a to the q. If I'm timing something with the same base number, what can I write that as like a simpler version? A to the power of p plus q. You add the indices. We know that. It's some like year 8 maths, okay? But it's in a slightly different context, to be fair. Let's take the a over. When it goes over to the other side, it becomes log base a. xy equals p plus q. But we said that p was log base a of x plus, and we said that q was log base a of y. So then we have proved what they wanted us to do. As long as you know about 3 days before the exam, doesn't really matter. You just have to sit down and learn them. They're not the most fun things all. I'm surprised I managed to do it. I only know it because I actually sat down and did it with someone yesterday. That's the only reason why I know it. Okay? Part B. We've got 2 to the power of 3 minus 5x equals 12. There are 2 ways to solve this. There's a clever way and there's a harder way. The harder way, older teachers tend to teach because that's how they were taught in school and they didn't have the calculators you've got. Okay? That's taking logs of both sides. I prefer not to do that because I don't tell you what I want to do instead. Take the 2 over and it'll become log base 2. Okay? That power then just becomes a normal sized thing. So it's log base 2 of 12. I can tell you now, there's no power of 2 that goes to 12, so I can tell you that'll be disgusting. Okay? I'm going to leave it in that case as log base 2 of 12, just leave it as that's neater to write. And I don't want my x being negative, so I'm going to bring that over to become 5x, but then I'm going to take over this log base 2 of 12, and then guess what I'm going to do with the 5? Yeah. I'm just going to be lazy. I'm going to cross out that 5 and divide the whole thing by 5. And then that just goes into my calculator. 3 minus log base 2 of 12 equals, divided by 5 equals, okay, it's a minus number and they wanted 2 in the question. It says to 3 decimal places. So it's minus 0.117 3dp.
So,
yes?
how do you know when to do, because there's another one, isn't there, where you say let u equal...
It will come up. It will say use the substitution. Let u equals this. Okay, it comes up very, very rarely. Very good memory. You've clearly been revising hard in logarithms to ask me that question. Yeah, it will tell you that substitution. Okay, we'll try and find something like that. Okay, before the exam, I swear. Okay, very easy way to check this, and you'd be silly if you didn't check. Go back to this line here and say 2 to the power of 3 minus 5 ands. What should I get? Ding dong. We got it, haven't we, Jess? Look. Little cheeky 12. Happy days. Yeah. And then C is requiring you to be pretty good at understand the difference between your logarithms. So let's have a look at it. Sir or surds? I didn't hear you.
Where did you get the divide by 5 from on the last?
It was 5x by here, so rather than actually doing what I should do, which is write it again, I just said, oh, we'll cross it out and divide that side by 5. Okay? Okay, that's not too bad. Right, logarithms, they've given us base 9, which means we can actually work with it, but the fact there's x's, we sort of can't work with it. So in some sense, you just said log or log base a or something. We can deal with those as long as they're all logs. That's fine. We like him. That's fine. But here's the problem here. There's 2. We need to rewrite that 2 somewhere else. Good. As a squared, as a power. Okay? So we'll rewrite that out as log base 9 of 3x minus 1 plus log base 9 of x plus 4 minus, and then we can write it as just log 9, and then it's going to be x plus 1 squared. If I add logarithms, what's that the same as doing? Times them. If I take away logarithms, what's that the same as doing? Divide them. So we can write that as a single logarithm by saying that it's log base 9, big bracket now, and then 3x plus 1, no, 3x minus 1, sorry, my bad. 3x minus 1, and then x plus 4, all over x plus 1 squared. Now, I don't think it's of any benefit to us to expand that out, because if you did, I think the only thing I'd say to you is say, oh, it looks a bit messy, can we factorise that? And then you just get it back to that. So I just leave it as that. Okay? It then says, oh, lovely. It then says, hence solve that thing equal to a half. This is easy for you lot. You lot are good at this sort of stuff. That is that thing above, isn't it? So we can now just put that equal to a half. We've got log base 9 equals a half. What are we going to do there now? How are we going to start solving it? Yeah, we're going to take the 9 over, aren't we? It's going to swing over into the half and become... Don't all shout at once.
That's square root 9.
It is. It's 9 to the power of a half. I'm going to write it as 9 to the half. Well done to Laura Jenny, who's identified well a half is the square root, but it's fine to leave that because you have your calculator. Your calculator will also tell you that. Okay, you can just take that as a positive number. You don't need to think about the square rooty bit here because otherwise you'll have too many answers. So you just tend to take it as the positive version here. So we've got 3x minus 1, x plus 4 equals 3. And what I haven't got is I haven't got the over x plus 1 squared. It's a bit fussy now. This is, I can see why it's 5 marks because I'd say we've got 3 so far. The rest is now just like a bit of a mission, just expanding it out and and collecting like terms and then factorising again. It's going to be a bit of a pain in the backside. It's going to take about 2 minutes. Okay, I'm going to start on that on a new page because I can see now that I'm not going to fit it on there. I'm going to write. So I've taken that divide by over to times by, but I'm also going to write out what the squared means. I'm going to just write out that it means times by itself. I'm going to expand them both sides. So I'm going to get 3x squared plus 4x minus x and then minus 4. And here I'm going to get 3x squared plus x plus 1. So that's 3x squared plus 3x minus 4 equals...
Shouldn't it be 12? Yeah. Instead of 4x. This is 3x times 4.
3 times... Yes, it should, yeah. Not an x, it should just be a 12, shouldn't it? Minus 12? Just plus 12?
No, it's
No,
minus
it's
3
not.
times 4x.
Let's try again. So what should it be? So 3x squared and then plus 12x minus x minus 4. So that bit's fine, isn't it? And then that's going to be x squared plus 2x plus 1. And then we're going to expand that to get 3x squared plus 6x plus 3. And here we've got 3x squared plus 11x minus 4. The 3x squares, take them off each side. Gone, cancel. Get your x's all on one side, numbers on the other. So 11x take away 6x is 5x. And then minus 4 goes over plus 4 is 7. So x equals 7/5. I told you that'd be a mission, as you saw. Very easy to make mistakes. Okay? And that's that bit done. We're on the home straight now. Doing well. Okay. Have a quick look at the question. I forget you haven't got it in front of you, sorry. That's alright, that is. Okay then. So, question 1, it says write down the coordinates of A. Okay, this is maybe a little bit different to what we're normally told then. So the points P is that, Q is that, they're either end of a diameter. Now, it's a very clever way you can do this. A is the centre, isn't it? Yeah? So if you draw generically, what 3 minus 8 is here, right? So then 5, 6 would have to be a bit across, but it's just going to be majority up, is it? It's going to be about there. Do we agree with that, roughly? Well, I want to find the middle of that. So basically, I just want to find the midpoint of the line. That's something from C1. So that's going to be the centre of A, which is going to be x1 plus x2 over 2, and that's going to be y1 plus y2 over 2, which is going to be 8 over 2, comma, minus 2 over 2, which is going to be, what, 4 minus 1? And just check it seems to make sense. 3, what's in the middle of 3 and 5? Obviously 4. Yeah, that makes sense, doesn't it? Okay. And then to show that, they want me to show that the radius is root 50. Well, you just need to go, this is all C1 stuff. It's effectively that. Find the length of a line. Okay? So it's going to be the square root of 5 minus 4 squared plus 6 minus 1 squared. Oh, okay. Sorry. I've been good now, up until now, haven't I? What's 5 take away 4? 1 squared is 1 plus 6 take away minus 1. 7 squared is, lo and behold, r equals root 50 as required. Okay. C, write down the equation, or part 3, write down the equation of C. Well, we always have it in form x squared plus y squared equals the radius squared. So the radius is root 50, so this would have to be just 50. They're going to be takeaways or pluses. We need that to be an answer that when we chuck in 4, it makes 0. So that would have to be minus 4. And when we chuck in minus 1, that has to be 0, so that has to be plus 1. Okay? That's 4 marks. Verify that 9/6 lies on C. That's this part here. Verify that 9/6 lies on C. Or 9 minus 6 lies on C. How do we do that? Easier way. There's an even easier way. Sub in, yeah. Okay. So x equals 9, y equals minus 6. Do we agree? Just chuck it into that formula there. It should equal 50 when we sub that in. So I'm going to say at 9 comma minus 6, we get 9 minus 4 squared plus minus 6 plus 1 squared equals 50. 9 minus 4. Don't all shout at once. 5 squared? 25. Uh-oh. What's minus 6 plus... Oh no, it's alright. It works, doesn't it? What's minus 6 plus 1? Minus 5. Minus 5 squared is also 25. 25 plus 25? Is 50. 50 equals 50. Tick. Therefore 9 minus 6 is on C. Okay? Now again, your drawing is important here. It says, find PQR. So I'm coming back to my drawing here, right? We've got this other value now, 9 minus 6. So that's like, so here's my circle. Ooh. Not as good as the one that was on the board a couple of weeks ago, I think we'll agree. So we've got 9 minus 6, so it's like somewhere over here. Okay? Now that's a diameter, isn't it? We're told that they're either end of a diameter, and I go and join that up there. It's actually checking that you know a rule from GCSE. What's this angle here at the centre? 180. It's a straight line, yeah? What's this one then at the circumference? 90. So what sort of triangle have I got? Right angle triangle. It wants me to use? Bit of SOHCAHTOA. Okay? We know what the hypotenuse is already. We know the radius is root 50. We know this radius will be root 50, so we've got 2 lots of root 50. So because this is a straight line, we know the angle at the circumference is half of the angle there. Circle theorems.
Isn't it like always two?
Anything that comes off a diameter always is a right angle. Always is a right angle, no matter what. So even if I put it there and there, that would still make a right angle triangle. Okay? So we know the hypotenuse is 2 root 50. They want me to work out QR, wasn't it, or PQR, so I need to actually know what these things were. So R was the 9/6, so R goes there. P was 3/8, so that must have been Q by there. So they want me to work out, which one was it, PQR? They want me to work out this top angle here, which I'll call theta. We either work out PR or QR, doesn't matter which one, and then we use sine, cos, or tan as a result. Okay, don't use tan because that's opposite of adjacent, then you have to find 2 things. We already know that. That's already root 50. Okay, so let's work out, which one do you want to work out, Caitlin? It's up to you.
Say that again.
Would you like to work out PR or find QR?
Let's do QR.
QR, okay. So QR is just the length of the line of formula again, so the square root of. So it's going to be the x's, the difference x's, so 9 minus 5. Now because I did 9 first, I have to choose minus 6 first. And then minus 6 minus 6. 9 take away 5. 4 squared. 16. Minus 6 minus 6. Minus 12 squared. Plus 144. So that is root 160. Don't bother trying to neaten that up. So now we know that is root 160. Do you want to know a very quick logical check to do here? What is root 160? Let's check it. It's 12 and a bit. What's 2 root 50? 14 a bit. Does that make sense? Yes, because that's a hypotenuse. I'm expecting it to be longer than that, okay? Just a logical check. You don't need to do that. This may be useful. That's the hypotenuse. I didn't realise it was so popular. That's the hypotenuse, and that is the adjacent. So, writing out, what would it be? It'd be cos, wouldn't it? Cos theta equals adjacent, so that is root 160 over hypotenuse, which is 2 root 50, and then take the cos over. Cos to the minus 1 of root 160 over 2 root 50. Now, I'm going to get math error when I press this. I'd do it to 1 if it was me. I'm going to get math error on that. Can anyone tell me why? Or syntax error. Can anyone tell me why? The bracket's just like, it's gone there at the back. You just have to delete that. You can actually press equals and it'll work there. Or you could have just had it at the back like that. Okay, and it still gives the same answer. So 26.6. Okay. I'm happy with that. It's good. Question 9, final one. Okay. So, quick look at the question. The diagram shows a circle, the points A, B, C lie on the circle, the angles are theta and phi, measured in radians. Radians. Let's go and deal with that now. And I sort of mildly disagree with what that guy was saying last week, where he's like, oh, it doesn't really matter when you're in it. So it doesn't matter, but on question, I'm just working radians all the time. Okay. So we're now in radians. It tells me that the sum of the areas of these two things here is 22.5. And I think the best way of doing that now is to write that in a statement. So I'd say area AOB plus area BOC is, that means equals 22.5 centimetres squared. And if you're doing like a really clever way of writing it, just try and write it hovering in the middle of a line. That's clever, isn't it? How do you find the area of a circle? How do you find the area of a circle? Pi r squared. Well, we haven't got a circle. We've got a bit of a circle, haven't we? We've got theta out of... Now, ordinarily, working circles, I'd say that's 360, but we're working in radians. 2 pi, good. So theta over 2 pi times by r squared, plus, and then this will be phi over 2 pi, pi r squared, equals 22.5. We can now do a nice little bit of subbing in and cancelling down, actually. You see the pi's? They cancel. There and there. Gone. And we're actually told the radius, and the question is 5. So we can change r for 5, so that is going to become 25 theta over 2 plus 25 phi over 2 equals 22.5. Any idea what I don't like about it at the moment? Don't like the over 2. So let's times every bit by 2. So we're going to get 25 theta plus 25 phi equals 45. What am I going to do now? Maybe a little bit easier for me because I could see there that they wanted theta and phi together. You can't. I keep forgetting you haven't got the paper, okay? It's my fault. So then 45 divided by 25, and I'm hoping that that's going to be 1.8 because they told me it is. Let's check it though. Lovely stuff. 1.8. Ooh, as required. Very nice feeling in exam when you get what they've said. Okay, Lewis, it's your favourite question. I remember having a lovely in-depth argument with you upstairs when this came up, okay? We've got a lovely bit of wording here coming up, okay? So, given that RKB is the key word here, is equals 3.5 centimetres longer than BC. Okay, I'm writing that in words now, okay? I'll write it in words underneath and then we'll just like copy the same thing. So I'm going to say RKB is arc BC plus 3.5 or 3.5 plus, doesn't really matter, okay? All good? Okay, so arc AB equals arc BC plus 3.5. Now let me just do a tiny bit of logic here. Does that make sense? So arc AB is, so that arc plus 3.5, yeah, that seems to make sense. That's smaller, isn't it? So it makes sense, but it's not drawn to scale, so just be mindful of that as well. But it tends to be a little bit to scale, where you can sort of say, well, that makes sense. What do we call the arc? What is the arc part of? The circumference, okay? So the arc is just a bit of the circumference. How much of the circumference? Well, theta over 2 pi of the circumference, so times by 2 pi r, would be equal to phi over 2 pi times 2 pi r, and then plus 3.5. Now again, we can do some nice cancelling here. 2 pi's cancel. 2 pi's cancel. R we already know is 5. So we can say that is 5 theta is equal to 5 phi plus 3.5. Say again. Do you think I made a mistake? It's fine.
Do you have to write it out and then cancel it?
No, you can write it. You can just learn them as r thetas if you want. Fine. Okay. I know. Right. I already know from what I've done before that theta plus phi is equal to 1.8. What I'm going to do, I'm going to rearrange to either 1.8 minus phi or 1.8 minus theta. Which one do you want? Doesn't matter. Let's sub theta. So that's 1.8 minus phi. Okay? So where I see a theta now, I'm going to change it to 1.8 minus phi. Then that is going to equal 5 phi plus 3.5. Okay? Expand the bracket, 5 times by 1.8. I think it's 9. Minus 5 phi equals 5 phi plus 3.5. The common misconception here is people go, oh look, the two 5 phi's cancel. They don't, because that one's plus and that was minus. Take that over, it becomes 10 phi. Take the 3.5 over, that becomes 5.5, I believe. Just be careful, don't do it in your head. It's not worth the risk really, is it? Yeah, it is 5.5. Okay, and then take the 10 over, so 5.5 would become 0.55. Is equal to phi. Therefore, if theta plus phi equals 1.8, theta equals 1.8 minus 0.55. And theta is equal to, don't know, not worth the risk, 1.25. And that is the full C2 paper done.